In this video, we are going to learn what is meant by a deadlock. That is, we are just going to see an introduction about deadlocks. So we are going to take up an example scenario and then find out what actually deadlock means. And if at all a deadlock is necessary in a system, then what are the conditions that are necessary for a deadlock? So this is what we're going to see in this video. Now let's take a very simple example. I'm going to now show you a scenario for a deadlock. I've got two students, namely Amy and Adam. Now, Amy and Adam, both of them are feeling hungry. Now, Amy is thinking of making an omelette for breakfast, whereas Adam is thinking of making a pancake for breakfast. So both of them want to eat as they are hungry, but each of them has got a different thought. So Amy wants an omelette and Adam wants a pancake. Now, the things that Amy will require will be, Amy requires egg for making the omelette, and she will require oil and of course a pan for making it. Whereas when you take Adam, since Adam wants to make a pancake, Adam will require the pancake batter, and he will also require oil and a pan for frying the pancake. So when you compare the items requested by Amy and Adam, you find that the common things that Amy and Adam will require is oil and a pan. Whereas the uncommon part is the egg for Amy and the pancake batter for Adam. So now how do we take up this scenario as an example for deadlock? Now, since Amy wants to make an omelette, let's assume Amy first takes up the oil. So Amy gets the oil for cooking. And let's assume that Adam, who wants to again make a pancake, picks up the pan. So Adam is grabbing the pan. Now, since there is only one bottle of oil and one pan available for them, Amy has already taken up the oil and Adam has already taken up the pan. So Amy cannot make her omelette because she does not have the pan and she's not able to take one because Adam is holding it. Similarly, Adam cannot make the pancake. Why? Because Adam has got only the pan and the oil required for frying the pancake is with Amy. So what is actually Amy doing? Amy is holding the oil and waiting for the pan. And Adam is holding the pan and waiting for the oil. So what happens? Look at this. What we will now see what they are waiting for. So look at this step number 3. Amy won't release the oil till she grabs the pan. That is, Amy has got the oil with her. She wants the pan so that she can complete her omelette. So she's not going to release the oil. Similarly, Adam also is waiting for the oil. Hence, he will not release the pan. So look at the step number 4. Adam won't leave the pan till he gets the oil. So now what happens? Look at this complete scenario. Step 1, as we saw, Amy has got the oil to start cooking, and Adam in step 2 has grabbed the pan. Step 3 says that Amy won't release the oil, and step 4 says that Adam won't leave the pan. So now how are they going to proceed about? Will Amy be able to make her omelette, or will Adam be able to complete his pancake? Now, if you look at this scenario, we will be able to conclude that neither Amy nor Adam will be able to make the omelette or the pancake for their breakfast. Why? Because each one is holding one item and waiting for the other, which is being held by the other person, and they are refusing to release it. This kind of a scenario is called as a deadlock. Why do we call it as a deadlock? Because neither Amy nor Adam is able to complete their task. So this is an example of a deadlock. So I hope you're able to clearly understand what a deadlock means. Therefore, now we proceed to the conditions which are necessary for a deadlock to exist in a system. Now we have 4 conditions which are necessary for a deadlock. The first one being mutual exclusion, and the second one being hold and wait. Third one is no preemption, and the fourth one is circular wait. So coming to the first one, if mutual exclusion, hold and wait, number 2, number 3, no preemption, and number 4, circular wait. If all these 4 conditions exist in a system, then we can say that the system is in a deadlock state. Clear with this? I hope you are able to understand clearly what it means. Therefore, if a system has to have a deadlock in it, all these 4 conditions must hold good. So let's go into the details of each of these 4 conditions. Now, first, let's look at what is meant by mutual exclusion. Right? So now if you look at what is meant by mutual exclusion is at least one held resource must be non-shareable. That is what is meant by mutual exclusion, right? At least one held resource must be non-shareable. Now coming to the next condition, hold and wait. There exists a process holding a resource and waiting for another. That is, a process will be holding a resource and waiting for another resource. That is what is meant by hold and wait. The third condition is no preemption. That is, resources cannot be preempted. Resources once given to a process, it cannot be preempted unless the process is completed. And finally, the fourth condition is circular wait. That is, you have a set of processes, say P1 to Pn, such that you are able to find a cycle formation between the processes. That is, P1 is waiting for P2, P2 is waiting for P3, P3 is waiting for P4, and so on, up to Pn minus 1 waiting for Pn and Pn waiting for P1. All these 4 conditions must hold for a deadlock to occur. Now let's go, or let's deep dive into each of the conditions. Now let's say, look into what is meant by mutual exclusion. As said in the previous slide, mutual exclusion is at least one resource which is being held by a process must be non-shareable. Non-shareable means it cannot be shared with any other process. That is the meaning of non-shareable. Now look at this scenario which is shown in this diagram. Now I have a changing room. Now they have got 2 people, customers getting into a shop, and they want to pick up a dress and then check whether the dress fits them. So I have a boy called A and a girl called B. Now both of them have picked up a dress and they are now proceeding to the changing room. Now when they are proceeding to the changing room, there is only one room which is available. Okay, I have only one room which is available, and that room is now marked as vacant, which means this room is capable of occupying one person currently. Now, so initially the changing room is vacant, and hence it will allow the people to enter. So whoever goes in first will be able to occupy it. Now what happens? Look at this diagram here. Now boy A has entered the changing room, and therefore now look at the symbol what is given here. The room has become occupied. The room which was vacant initially has now occupied by boy A. Now, although the girl wants to change, she will not be able to change unless the boy comes out, right? Which means unless the room becomes vacant once again. So this is something which is not shareable. This changing room is a non-shareable resource. So when boy A is using the changing room, girl B cannot use the changing room. This is what is meant by mutual exclusion. I hope you're able to understand what is mutual exclusion. Now coming to the second condition of hold and wait. Now look at this example for hold and wait. Now look at this. Amy wants the laptop. Okay. And who is having the laptop? John is having the laptop. So John is having the laptop, and John will not give the laptop to Amy till he gets the remote. Right? And who is having the remote? Amy is having the remote. So what happens now? Amy is holding the remote and waiting for the laptop. John is holding the laptop and waiting for the remote. So now we have a hold and wait scenario here. Amy is holding the remote and waiting for the laptop. John is holding the laptop and waiting for the remote. So this is a hold and wait scenario. So this is an example for what is meant by hold and wait. Now coming to what is meant by no preemption. Now in the previous slide where we defined what is no preemption, it was clearly stated that if a resource is given to a process, it cannot be taken away from the process till the process has completed it. So look at this scenario given here. Now, what do you observe from this scenario? See, now I've got two processes, process 1, process 2, right? Now, resource 1 is allocated to process 1 and resource 2 is allocated to process 2. So even though process 2 is requesting for resource 1 will not be released by process 1 unless process 1 completes its job with resource 1. So this is called no preemption. Once a resource is allocated to a process, the process will not release the resource until it has completed its job with the resource. This is what is meant by no preemption. Now coming to the last condition, which is circular wait. Now circular wait is very simple. That is, I've got here in this example 4 processes. Process 1, process 2, process 3, process 4. And I have got 4 resources. Resource 1, resource 2, resource 3, and resource 4. Now, if you look at the way in which the circular wait is being shown, see P1 is waiting for R2 held by P2. P2 is waiting for R3 held by P3. And P3 is waiting for R4 held by P4. And P4 is waiting for R1 held by P1. So you have a cycle being formed. P1 waiting for P2, P2 waiting for P3, P3 waiting for P4, and P4 waiting for P1. So there is a circular wait being formed. So this is what is meant by circular wait. So if all these 4 conditions hold good in any snapshot of a system, then we can say that there is a deadlock in the system. Now, I hope you are clear with what is meant by a deadlock and what is meant by the conditions. What are the conditions necessary for a deadlock to occur? So with this, we will end up this video. Thank you.